Now we're going to look at spring 2006, number 13, where we have the derivative of the integral function. In class we had called this function g of x, this area accumulating function, and we had an example in class where the lower limit and the upper limit were both functions of x. So when applying the fundamental theorem of calculus, part 1, we had said that it's necessary to find some number that can be plugged into both functions, and essentially we're trying to take the derivative of g, and so what we're going to do is rewrite g to be the integral from x to 1 of the square root of x squared of square root of 1 plus t squared, and then also the we're going to add to that then the integral from 1 to x squared. So that we recognize that the first one is in the reverse order of what we need it to be, and so we can say that that is going to be then the second integral minus the first integral. Minus the first integral, but then flipped, so that the order of operation, the limit of integration is correct. Great. So sorry. Let's try that out. That's not working out. Sorry. Let's take this whole thing and move it down here. Okay, there we go. Sorry about that. Okay. This is still all g of x. And so we are basically asked to find the derivative of g of x. And so g prime of x is going to be us applying the fundamental theorem of calculus part 1 to both of these integrals. Now the first one is for us to replace t by x squared. So we'll get the square root of 1 plus x squared, then squared, but chain rule would be we have to multiply by the derivative of x squared. And then to that we subtract just the derivative of the second one, which is just replace the t with an x. No need to worry about a chain rule there, or if you want, the chain rule has 1 as the derivative of the x. And so we recognize this as x to the 4th, so 1 plus x to the 4th underneath a root times the 2x minus the root of 1 plus x squared, which looks like letter A. Great.